Hey, so welcome back, and this is another daily code problem. So today it's called non-overlapping intervals. Now I actually did this one yesterday, but I thought we'd do it today. And so essentially, what you're given here is just a two-dimensional array, or I kind of like thinking of it as really just a list of tuples. That's how I think of it. And essentially, all that you want to do is you want to picture these kind of like in a time series. So this will indicate the time, and it's basically a timeline starting at 0, and you can imagine 1, 2, and then 3, and like so on. So this could be like 4. And so what this kind of looks like in this graph here is the interval 1 to 2, that would start here and go all the way up to 2. Then 2 to 3 would look something like from 2 to 3. 3 to 4, well, that's like this. And then 1 to 3, well, that's essentially from here all the way to here. And so what you want to do is essentially remove the minimum number of intervals so that there's no overlaps. And so if we're looking for that, essentially what you can see here is that the only one that really causes overlaps is this one here. These ones are fine because, well, although they touch, they don't really overlap, so that's okay. So these two cases are fine. The only thing that you really care about here is that this one actually hovers over these other two. And so naturally, if we just kind of broke this one or removed it, thus incrementing our count from 0 to 1, it only took one removal so that none of these intervals are overlapping. And that's actually your answer here, 1. All right, and so essentially, the first thing that I thought of when I was trying to solve this was, okay, it's kind of confusing hopping around here to find these interval ranges. So just by sorting them, it just made it a lot more intuitive for me. And so that, in this case, is just moving 1, 3 to basically this location here. So it looks like 1, 3. All right, so it goes 1, 2, 1, 3, 2, 3, 3, 4. I kind of toss in my head of, okay, what if we wanted to sort it by the second number and then the first number, like maybe changing the sorting algorithm a little bit. But you don't actually have to do that. You just have to think about sorting it from the first value, then the second value, if that makes sense. And so from here, the only things that you have to keep track of is essentially the count, because naturally you're going to be incrementing the count. But other than that, the only thing that you really need to be thinking about is the previous interval or end interval number. Okay, and that's the key to everything here. And so initially, the previous end interval number will be 2. Like, when did the previous interval end? Okay, and so essentially, you're just going to be looking at from the first interval, like index 1, not index 0 onwards. So you set the previous to 2, and then you look at basically this interval and these ones onwards from that. And so you're just comparing, okay, did this interval end before this one start? If not, then naturally there's an overlap. Otherwise, you just take the new ending as the current interval. Okay, if that doesn't make much sense, I think me showing you the code and just relating it back to this diagram here, it might make more sense, so try to stay with me. And so once again, the first thing that we want to keep track of is naturally the count, because that's what we're going to want to return here. And we're also going to want to sort this for simplicity. This does cost n log n time complexity, so it's going to be the bottleneck for this algorithm, but it's a great benefit. Otherwise, you're going to be reiterating and pointing back and forth, and it'll be more of an n-squared algorithm, so it's worth the cost. And so from here, what you want to keep track of is what is the previous end time. So I'll call it like previous end as the variable. And so this is going to be essentially the first interval in our list and basically the end of that interval. And so once again, we're just going to iterate through all these intervals from the first index onwards, because we don't want to consider the first index here because that's our previous end. So that just looks like in Python like that, because you can just use Python slicing to simplify it. And so once again, there's only 2 different cases that we have to consider. And so we can just use an if else for this. And the first case is, what if there's no overlap? So the previous the previous interval ends before the current one starts. That's the key for this first one. So if the previous interval ended before the current one even started, that's fine. Let's just update the new previous end date. And so what that looks like in an if statement is just, okay, is the previous end less than or equal to, because it's fine if they touch, they just can't overlap, the current interval, we'll call this interval, its start time. So we check if the current one started after this one has ended. And so then naturally we just want to update our new previous end to this new end. Oh, and to do the starting one, we want to do index at 0. Sorry about the confusion. And so from here, this case is there is an overlap. And so we want to handle that overlap and basically, once again, increment our count, but we also want to update this new previous end pointer. And so the reason is for that is because, well, this the previous interval's end time has ended between this interval range that we're currently looking at. And so the key to solving this problem is we want to take whichever one ends earliest. Because if you take the previous end time of a date or a time that ends like kind of later on, there's a higher probability that it's going to overlap with an upcoming interval. So let's just take the one that ends the earliest so you don't have that problem. And that's how you basically get the minimum number of intervals. Okay, and so in code, what that looks like is let's just compare the current previous end time with the current previous end time. All right, so let's try running that. Looks good. And success. So for time and space complexity, well, our time complexity is going to be n log n because this sorting is the bottleneck. And for space complexity, well, the only storage that we're really using here is constant space variables. So you don't have any space complexity. So it's just O of 1 or constant space. But yeah, I hope this helped a little bit, and good luck with the rest of your algorithms. Thanks for watching.